All right, today we're going to pull back the curtain on one of the most incredible industrial processes out there, oil refining. We're going to see how that thick, black stuff that comes out of the ground gets transformed into the super important fuels that literally power our world. It's a pretty amazing journey of chemistry and physics.
I mean, really think about it. How in the world do you go from that raw, dark crude oil to the perfectly clear liquid that you need to get a 747 off the ground? It seems like it has to be some kind of magic, right? Well, it's not magic. It's just really, really clever science. And by the end of this, you'll know exactly how it works.
Okay, so the whole secret, the absolute heart of the process, is something called atmospheric distillation. Here's the big idea. You heat up the crude oil till it turns into a gas. This hot vapor then rises up a huge tower, and as it gets higher, it cools down. At different levels, different parts of the vapor cool enough to turn back into a liquid. The lightest stuff makes it all the way to the top, and the really heavy gunk stays at the bottom. Simple as that. Now, to really get what's happening, you only need to know one simple rule. We're going to call it the C number. It's just the number of carbon atoms in any given molecule. And here's the rule. The more carbons, the heavier the molecule, and the hotter you have to get it to boil. That's it. That one little principle is the key to this whole shebang. So let's start our tour where it makes the most sense. Right at the very top of the distillation tower. This is the penthouse suite, where all the lightest, most energetic compounds hang out, the ones with the lowest boiling points and the smallest C numbers. So the first thing we pull off the top is called naphtha. Now, this isn't something you'd pump directly into your car. Think of it as a key ingredient. It's super light with a C number between 5 and 10. But before it can become gasoline, it needs a serious cleaning. It gets sent to this machine called a hydrotreater, which cleverly uses hydrogen to grab onto nasty stuff like sulfur and pull it out. Only after that crucial step is the naphtha pure enough to be blended into the high-octane gasoline we all depend on. Okay, moving on down the tower now. As we go lower, things get hotter, and the molecules start getting bigger and heavier. This is where we find the real workhorses, the fuels that power our big trucks, our ships, and our airplanes. And here is a really cool fact. You know the kerosene some people use for heating their homes? Well, that is the exact same base liquid that after some pretty intense treatment becomes jet fuel. It's got so much energy packed into it and it burns so cleanly that it's perfect for both jobs once it's purified to meet those super strict aviation standards, of course. So in this middle section, you can see how things are similar but just a little different. Kerosene and what becomes diesel, that's light gas oil, are basically next-door neighbors in the tower. You can even see their C numbers overlap. And they both get purified with steam in a machine called a stripper, which literally strips out any lighter bits to make sure they're stable and safe. But even though they're so similar, their jobs couldn't be more different. One takes to the skies, and the other powers the roads. Let's keep going down. We're now arriving at the bottom of the tower. It is seriously hot down here, and what we're left with are the molecules that just refuse to boil any earlier. This stuff is dense, thick, and way heavier than anything we've seen so far. First up, we get what's called heavy gas oil, or HGO. I mean, look at that carbon count. We're talking chains of 20 to 40 carbons. This stuff is way thicker than diesel. You're not using this as a fuel directly. Instead, just like naphtha at the top, think of it as another valuable raw material that's headed for a totally different process later on. And then, at the very, very bottom, you find what's called atmospheric residue. We're talking molecules with more than 40 carbon atoms. This is the true bottom of the barrel, the heaviest, goopiest stuff left over from this first big separation. But, and this is a big but, this is not waste. It's a treasure chest of really complex, valuable molecules. Okay, so we've collected all this heavy stuff like HGO and the residue, but now we have a big problem. There is a ton of values still locked up in these thick liquids. I'm talking things like lubricating oils or the asphalt for roads. The problem is you can't just crank up the heat to get it out. So, to get that value, to unlock the potential of these super heavy molecules, we have to change the rules of the game. We can't stay at normal atmospheric pressure. Our journey has to continue in a totally new environment. So here's the catch-22. These heavy molecules have boiling points that are sky high. If you try to heat them enough to boil, the intense heat would literally just shatter the molecules themselves. It's a process called thermal cracking, and it would destroy the very things you're trying to collect. So how do you boil something without completely burning it? Well, the solution is absolutely ingenious. If you can't raise the temperature, you lower the pressure. You know how water boils at a lower temperature at the top of a mountain? It's the exact same principle. All that heavy gunk gets sent to a vacuum distillation unit, or VDU. By basically sucking all the air out, they create a vacuum that lets these heavy oils boil at a much cooler, safer temperature. No more thermal cracking, and they can separate out even more valuable products. And that really brings us to our final thought. That first distillation tower, that gives us our essential fuels like gasoline and jet fuel. But it's this clever second step, under a vacuum, that unlocks a whole new world of products from the heaviest parts of crude, everything from the lubricating oils that keep our engines running to the very asphalt that paves our roads. It just makes you wonder, what else is hidden down there in the bottom of the barrel, just waiting for a clever process to unlock it?